Hi, I'm Charlotte Louise from Plunging.com, and today I'm going to do a quick video tutorial on how you can find the time that it takes for a projectile to get to the top of its motion, and also the displacement that occurs when it does that. And these equations are going to be really useful for equations that you're going to use later on in physics. So in our last video, and this is just sort of a general physics equation too, we showed that the displacement is equal to the initial displacement plus the initial velocity times time plus 1/2 the acceleration multiplied by the time squared. So using that equation, we're going to look at a projectile that's just shot straight up. And this is a pretty common physics problem. And basically, you'll be given just an initial velocity, most likely, and then asked to find how long the projectile's in the air, or how long it takes the projectile to reach the top of its motion. So it's going to go straight up and then come back down. I'm drawing it coming down a little bit to the side just so you can see what I'm doing. But basically, one of the first things that I would realize about this is the minute that you've let go of a ball in your hand that you're throwing up, or a projectile's been forced out of whatever it's being shot out of, the only force that's then acting on it, so I've got this projectile in the air, is just gravity. And that's one that physics professors will try and trick you up with a lot. So just remember that once it's let go, the acceleration is just equal to g. But going from there, sort of the first thing that you need to do in a problem like this is just define which direction you're going to call positive. I almost always call up positive, but occasionally you'll get a projectile that's shot down, and then what we're going over today doesn't really have to do much with it. But if you get that, where you have an initial velocity going down and you have an acceleration going down because you just have gravity acting on it, and this is more like just a ball being dropped. I'm not even going to write that. But in that case, then you'll probably just define down as positive, so you're not having to work with two negatives. So that's just sort of a side note, but you always want to make sure that you're defining a direction here. So we're calling up positive. So in that case, using this equation, we know that our displacement when we get to the top, so displacement at the top, how far up it's going to go, is just going to be equal to vi times however long it takes to get to the top minus 9.8, because we're using SI units, divided by 2 times t squared. And that time is also going to be the time at the top, just like this is going to be the time at the top. So from there we can see what we really need to know is how long this projectile is going to take to get to its top. So hopefully you guys have sort of seen these v versus t graphs before. And looking at this, we know that for a while v is in the positive direction, but it's going to be slowing down because the acceleration is in the opposite direction. So it's going to be positive but slowing down. And then at some point it starts heading in our negative direction. So that means v has to cross this 0 line and start going negative. It's going to be a constant slope line just because our acceleration is the same thing the whole time. It's just equal to negative 9.8. So we can see that at some point the velocity is equal to 0. And we actually know that that's going to happen right at the top because that's when our ball or projectile, whatever it is, turns around. So that's going to be really the key to figuring out what the time is at the top. And we're going to use this equation right here. And we already talked about how I have an average acceleration, but we know that that's just always going to be average, so we just use A. So basically from there, we know that our final velocity, because we're calling by final just top, so we're ending it right here. So we're saying right there, the velocity is equal to 0. So we're going to say 0 equals VI minus 9.8. And that's a minus because VI is positive direction, and our acceleration is negative again. And that's T top, the time at the top that we have a 0 for our final velocity. So from this equation, we can basically just see that VI equals T times T top by moving this over to the other side. And then we can see that our T top is just going to be equal to VI over 9.8. So that basically allows us to figure out exactly how long it's going to take us to get to the top, which we can plug in, and then we can figure out exactly how high up the projectile will get. And pretty often you'll be asked not necessarily the time that it takes to get to the top, but how long the projectile's in the air. And the total time, T total, is just going to be equal to twice T top, which is equal to VI over 4.9. And just another quick note, right here we're just looking at projectiles in one dimension, which is probably what you'll do first in your physics class. And then you'll go on to projectiles in 2 dimensions. And the only thing that really changes is everything that I've just done here is only looking at the y direction. We're just looking at up and down. So because of that, when you change to projectiles in 2 dimensions, what you'll need to do is basically just wherever I have a VI, you're going to say that's VI in the y direction. So these ones are VI in the y direction. And that's just basically going to change it up a little bit, but it's nothing big. So that is the end of my video tutorial. I hope you enjoyed.